Okay, so good day. So today we are going to discuss the methods of section. So what's the difference of this method from the method of joints? Now, the method of joints is advisable if you are going to determine the forces for each members of your truss. But if you are only going to determine two or a very specific number of um, forces for each member, it is advisable to use the method of sections because you can skip several number of members to deal with. Okay, so the principle of equilibrium of non-concurrent force system can be applied to this method of section. Okay, so the procedure is known as the method of sections. So we can determine directly the force in almost any member instead of proceeding to that member by a joint to joint analysis. So this will be the advantage of the method of section from the method of joint. Okay, so we can determine directly the force in that particular member. So instead of using the method of joints wherein you have to uh, solve or you have to determine the forces using a very long method. Okay, so in this type or in this method, you can use the three conditions of equilibrium, which is also applicable for non-concurrent force system. Okay, so you have the summation of forces vertical, you have the summation of forces horizontal, and the summation of moment at any point is equals to 0. Okay, so we have this illustrative problem. From the truss in the figure, determine the force in members BC, CE, and EF. So we have this member BC, we have this member CE, this member, this diagonal member, and then we have this member EF. Okay, now you see we have three unknowns, but we have also three available equations or conditions of equilibrium, meaning we can solve the problem. But before you apply the methods of section, you should start with or you should start in determining the reactions at the support. So since this problem is the same with the previous problem that we have solved, so it is known that A vertical is 3.33 downward and A horizontal is also 80 kilonewton. Okay, then we have RD, or the reaction at D, which is 53.33 kilonewton. That is based from the previous example. Okay, so to solve for the forces in members BC, CE, and EF, we have to pass a section passing through those members. Okay, which we call as section AA, passing through the unknown members. So by doing that, we have to expose the forces. Okay, mo man ang singikat. So expose the mga forces, internal forces acting on those members. You can assume that those forces are in compression or in tension. So whichever assumption you are comfortable with, you can do that. Okay. Now, considering the right section, since we are using the reaction at the rocker or roller D, we have 53.33, so we will consider the right section, and assuming that all forces, internal forces acting in each member for katong naigo na to sa atong section ganina, katotanan is poros to sila mga tension. Okay, so from the FBD of the section through AA, we will we can solve directly the value of FBC by taking moment at point E. Okay, so we have ato rang i-project, ato rang i-diretso ang ato ang forces, mag-intersect na sila at point E. Okay? So we can, if we take moment at point E, we can eliminate FCE and FEF, therefore solving directly the value of FBC. Okay? Taking summation of moment at point E is equals to 0, assuming counterclockwise. If you see this symbol, this is counterclockwise moment positive. So all forces that will create a counterclockwise moment about point E, ato na siyang tagaan o ato na siyang isuwat as positive. So meaning ang tanan nga counterclockwise will be negative. I mean tanan nga counterclockwise positive, tanan clockwise will be negative. So we have for FBC, the moment arm will be 0.75. So we have 0.75 BC plus 2 RD. So EF is 1, FD is 1. So the moment arm for RD will be 2 meters. So 2 RD, which is equals to 0.75 times 80. So since 80 kilonewton will create a clockwise moment about point A. So ang rotation is paana. Ang rotation sa imong 80 kilonewton nga load. And then plus 50 times 1. So ang 50 is will also create a clockwise moment about point A. So that is plus. So substituting the value of RD, which is 53.33, you have your FBC is equals to 4.45 kilonewton, which is in tension. Again, we have arrived with a positive answer, meaning our assumption that FBC is in tension is correct. Okay, so our the value of FBC is 4.45 kilonewton tension. Now, we already only have two remaining unknowns, the FCE and FEF. We can solve for the value of FEF if we take moment at point C, because we can eliminate FBC and FCE. Okay, so we only have one unknown, EF. So taking moment at point C is equals to 0, assuming excuse me, assuming clockwise moment positive. So everything that will create a clockwise moment about point C, ato na siyang hatagan o positive nga sign. So ang maka-create o counterclockwise moment about clockwise moment about C is FEF. The moment arm for if FEF is 0.75. So we have 0.75 FEF is equals to the 1 RD. So RD will create a counterclockwise. So that is minus. So ang ibalhin dito sa pikas nga side. So equals to 1 RD. RD is 53.33. You substitute, you solve for FEF, you have 71.11 kilonewton, which is in tension. So again, we have arrived with a positive answer, meaning our assumption that FEF is in tension is correct. Okay. And then we only have one remaining unknown, which is FCE. You can still use the summation of moment at where asa man ta dapita at point F. Pwede na nimo gamiton masolve nimo ang FCE, or at point D masolve gyapon nimo ang FCE. But ang simple nga paagi ra is you use summation of forces vertical is equals to 0. So considering this member FCE, this is your vertical reaction, or I mean vertical component of your member FCE, so that is downward. So summation of forces vertical is equal to 0. You have FCE vertical plus 50 is equals to 53.33. So vertical, you have FCE sine of theta, that is 3 over 5 plus 50 is equals to RD. So your FCE is 5.55 kilonewton, which is in tension. Again, we have arrived with a positive answer, meaning our assumption that FCE is in tension is correct. Okay,